Well, pretesting is what I've been calling all my career piloting. Yeah, some people call it pretesting. Essentially, it's when you take language test items and try them out with a group of students similar to the ones who will ultimately take the test. Yeah. For instance, you might be writing a set of items for a placement test designed to determine which level of study the students ought to be in when they do their language studies. And we do write items so that we get them at about the right level of difficulty. We do our best. And we know basically what kinds of items will discriminate between our top students and our bottom students. The pretesting allows us to actually try it. We give it to a group of students similar to the ones who will take the test, and then we look using some very simple statistical techniques to determine whether the items really are at the right level of difficulty and whether or not they can discriminate between our best students and our worst. Yeah. Basically, I mean, in short, as test developers, we'd like to select those items for future versions of a test that work the best with our students, and so we use these techniques to try to do that.
Why do we need to do pretesting items?
Well, basically because we don't know as much as we think we know. In my experience, I'll write items that I think are going to work, and about 2/3 of them actually do. And the problem is that we have to find, through pretesting, which of the items actually do work and which ones won't. Yeah.
Are there statistics that we can use to help us select items to keep for a revised version of our test?
Yeah, there are statistics. There are simple statistics, actually. The word statistics often frightens people, but these statistics are simply percents that you can use to help understand how well your items are working. Usually what I do is I run the items through a certain series of steps. Like I try to develop more items than I need ultimately. So if I need 30 items on the final version of the test, what I'll probably do is develop 45 or 50 items of the types that I think will work. That's my first step. And then I actually administer them to some students like the ones who will be taking the test. And this can be done in a number of different ways. I mean, obviously you don't want to test the students who will be tested ultimately for the decision making. But you can use students in previous semesters, or you can use students at different geographical locations. Some places they even secrete small sets of items in other tests to see how they're working. One way or the other, you need to get students to take the tests, and that would be the second step. And then what I'll typically do is code the items either on a sheet of paper in rows and columns with grid lines, something like that, where I code them 1 for correct and 0 for incorrect. More often I actually do it in a spreadsheet program like Excel or Quattro Pro, just because it's easier. But either way, the statistics are very easy if you can code them for 1s and 0s for right and wrong, each student getting a row, so all of their answers being coded in a row, and each item getting a column. Yeah, like in the example matrix that you have on the screen in front of you, where the students' names are down the left-hand side, and then each of the items gets a column, I1, I2, I3, over to the total. Now, obviously, the total scores indicate that I've got more than 7 items, but I only put 7 as examples here. Yeah. And then each student's scores are there. Kimi got the first item right, as you can see, second item wrong, third item right, and so forth, for a total of 48. Yeah. So that third step is to code the items in such a way that you can manipulate them and figure out what's going on. The first actual statistic is called item difficulty. This is where we figure out the percentage of students who answered each item correctly. You do this by simply counting up the number of 1s in the column for that particular item and dividing by the total number of people. So for item 1, we've got 10 1s and 10 people. 10 divided by 10 is 1.0. Clearly then 100% of the students answered this one correctly. In item 2, the opposite is true. Nobody answered this one correctly. And then item 3, it appears that 5 people, there are 5 1s, answered it correctly, and there are 10 people total, so the item difficulty would be 0.50, indicating that 50% answered this item correctly. Essentially what we're trying to figure out with this item difficulty is how many people or what percent of the people are answering this correctly, so that we can gauge the level of difficulty of our test by selecting items that are at the right level of difficulty. Yeah, that's the fourth step, item difficulty. The fifth step involves calculating something called item discrimination. And this involves dividing the students into three groups, basically. You can see that in the example matrix, I've got the upper group. According to their total scores, they're arranged from 48 down to 18 in order. You can see that over on the right. And the upper group is separated. The upper three students is separated from the middle group, which in turn is separated from the lower three students. I chose to put 4 in the middle, 3 at the top, 3 in the bottom, because I wanted the top and the bottom groups to be of the same size. Notice also that 2 students, Kazuko and Hachiko, both got 29, yet they ended up in 2 different groups. This is because that's where I wanted to draw the line, and I just randomly, literally randomly with a coin, figured that Kazuko would go into the middle group and Hachiko into the bottom group. And so once you've got those groupings set, then the rest of it is very, very easy. You simply calculate item discrimination by first figuring out the item difficulty for the top group, and then figuring out the item difficulty for the bottom group. So for the top group, on item 1, the item difficulty 3 divided by 3 is 1. And for the bottom group, 3 divided by 3 is 1. And then you subtract. So you see I've got a row at the bottom of the table. Item difficulty for the top is 1.0. Item difficulty for the bottom is 1.0. And you subtract. You subtract the bottom from the top, and that gives you, in this case, 0. That means that the item doesn't discriminate at all, and that makes sense when you realize that the item is being answered correctly by all. Same thing happens with item 2 for different reasons. Nobody in the top group got it right, nobody in the bottom group, so when you subtract, you get 0.00. Yeah? An item that looks more like what we would like to actually end up with in a placement sort of situation is item 3, where Kimi, Mariko, and Yuri all got it right, item 3, and so they would have an item facility in the top group of 1.0, whereas the 3 in the bottom group, Hachiko, Yoshinori, and Yuichi, all got it wrong. 1 minus 0 equals 1.00, which indicates very, very good discrimination. The fourth item, we see the opposite happening, where the bottom group is getting it all right and the top group is getting it all wrong, and that turns out to be 0 minus 1 turns out to be minus 1.00. That's very bad discrimination. You might want to look more closely at that item and see if you really want to keep it in the test at all. It's doing something quite different from the other items, and so forth. So those are the 2 basic statistics, the item difficulty and the item discrimination indices, and we use them both then in deciding which items to keep.
Once we've revised our test, can we trust it indefinitely?
Well, what you've done essentially is you take your 50 items and you select the best 30 in terms of item discrimination first, and then in terms of the difficulty level, and you know then that your items fit the group of students that you're trying to test in all probability. And for a short term, that will be true. The problem is that for security reasons or because of changes in the populations in a given institution, even items that were working really well at one point in time may not work forever. So it's probably a good idea to check the item difficulty and the item discrimination on an ongoing basis. Particularly for non-reference types of decisions that I'm talking about here, the kinds of placement or proficiency tests that we do in language